So in this video, I'm going to solve a problem on by using KCL and KVL, so which is a IIT tutorial problem. So this is the problem: calculate VAB in figure. So this is the figure given. So I have taken this problem from IIT tutorials, and this is the circuit. It looks as a complex circuit, so but it is a very easy problem. So here calculate VAB in figure. So this is A node and this is B node, and here we have to solve voltage in between these two nodes VAB, which is called as VAB, and also calculate the current through 5-volt source. So what is the current given by this 5-volt source? What is the current in this 5-volt source? So this is a problem taken from IIT tutorials. Uh, so first step is, so let us try to solve VAB first. So to solve VAB, so I have redrawn the circuit. So taking the circuit as it is, and he is saying that the voltage from A node to B node is VAB, and always towards A positive polarity and towards B negative polarity, or towards A negative terminal, B is a negative, A is positive terminal and B is negative terminal. If you write a KVL in this loop, so KVL in this loop, so I can write like this. So we can, if this is A, this is also A, this is also A node, because it is a short circuit. So if it is B, this is also B, so this is also B, and so let's suppose this is a C and this is a C, and let's suppose this is a D, and this is a D. So I'm taking names, assigning names to the nodes. Let it be F, and let it be Z. So we have given the names to the nodes, so it becomes easy. Now I am writing KVL in this loop. So this is the path I am following for the KVL. So I am starting at this point, and I am traveling in this direction. So in this direction, so to write KVL, so I am starting at this point. So I come across a negative sign, so minus, and the magnitude is VAB. Next, after that, I come across positive sign, plus voltage is 10 volts, and again I come across negative sign, minus, and voltage is 20, and after that I come across positive sign, plus voltage is 5, and after that I come across positive sign, plus voltage is 20, and after that I come across negative sign, and here it is 10 again. So where I started, so I came to the point where I started. So I started at B node, so again I reached the same B node. So now this algebraic sum is 0. So if you rewrite this equation, so VAB is equals to 10 minus 20 plus 5 plus 20 minus 10. So this 20 cancels with this 20 and this 10 cancels with this 10. So left over is 5. So VAB is equals to 5 volts. So this is as simple as that. So very easy. It looks very difficult, but it is a very easy problem. So similarly, now let us try to solve for a B question. So B problem. So before solving for B, so here it is a open circuit. So here he is asking only voltage in between A B nodes, and there is no current in this branch. Here it is a volt, just it is a voltage. So that voltage is 5 volts. Now to solve current in this 5 volts, let us solve. So here by applying KVL in this loop, so by applying KVL in this loop, so already 10 volts is there. So from A to C, so voltage should be 10 volts. So already from F to C there is voltage 10 volts. Now what is the voltage in between AF such that in between AC voltage should be 10? So already 20 is there. So you have to subtract 10. Means, so it becomes minus, it becomes plus, and voltage is 10 volts here. So minus 10 plus 20. So altogether it comes as 10 volts. So voltage in between A and F is 10 volts, and negative polarity towards A and positive polarity towards F. And so similarly we can solve this problem. So here from G to C, voltage is so minus 5 plus 20. So altogether it comes as 15. So means from G to C voltage should be 15. So plus minus 15 volts. So again from A to C voltage should be 10. So from A to C voltage should be 10. So from G to C already 15 volts is there. Now we have to subtract 5, means taking minus here, so taking plus here and taking 5 volts here. Now voltage from A to C is 10 volts. Now we can get so similarly we can get voltages here. So because these three elements are connected in parallel, means voltage is same. So if it is 10 volts, so voltage across 5 ohms is 10 volts, voltage across 10 ohms is also 10 volts. And positive polarity, so this is positive polarity and this is negative polarity, and voltage is 10 volts. So here also voltage is plus and minus, voltage is 10 volts. Now let us get currents. So if voltage is 10 volts, 10 by 10 is current, and that current is flowing always in passive elements. Current enters at positive polarity, so current is 1 ampere. So similarly this is a resistor, passive element, current enters at positive polarity, 10 by 5 is the current. So here it is 2 amperes. So this current comes as 2 amperes. And so here this 2 amperes and this is 1 ampere. So that total current, if you apply KCL at this point, we get 3 amperes as a current. So this 3 amperes is divided as 2 amperes and 1 ampere. And again, so here what is the current? So out of 2 is coming like this, 1 is coming like this, and net current is flowing in this branch 3 amperes. So here there is no current, 0 amperes. So whatever the current 3 amperes is flowing in this as 2 amperes, and this 3 amperes, out of 3 amperes 1 ampere is flowing in this direction. So 2 and 1. Again this 2 amperes comes as join at this dot, at this node. So 2 plus 1 comes as 3. So this total 2 amperes is coming to the 10 volt source. This 1 ampere is coming to the 10 volt source. So that's why there is no current here. And here what is the current in this branch? So 5 by 10. And this is a passive element. Current enters at positive polarity. So current is 1 by 2 amperes or 0.5 amperes. And here 15 volts by 3. So V equal to Ri. I am using V equal to Ri relation. So 15 by 5 is the current in this branch. and current enters at positive polarity, so here it is 3 amperes. And here, so V by R is the current, 10 by 5 is 2 amperes, and that 2 amperes comes like this because current enters at positive terminal in the resistor. So here 0 amperes is coming from this 20 volt source, but current in this is 0.5 amperes, current in this is 3 amperes, means that 3 plus 0.5, 3.5 amperes is coming from this source. There is no other way, so only that 3.5 should come from the source. So current in 5 volt source is 3.5 amperes. So current current in 5 volt source, current in 5 volt source is 3.5 amperes. So similarly, we can also find current in remaining sources. So current in 20 volt source is 0 amperes, current in 10 volt source is 3 amperes, and 3 amperes is coming like this, and 2 amperes is going like this. So from this node, this 3.5 is leaving and 2 amperes is also leaving. So definitely that 3.5 plus 2, 5.5 amperes should come from 20 volt source. So this is 5.5 amperes of current is coming from 20 volt source. So 2 amperes is coming to the node and 0.5 is coming to the node. That net current will flow to this 10 volt source. So current in this is 2.5 amperes. So 2.5 amperes. So 2.5 amperes. So in that way we can find current in all the voltage sources. So current in this voltage source is 3 amperes, current in this voltage source is 0 amperes, current in this voltage source is 3.5 amperes, and it is absorbing power. It is not giving power, it is this 5 volt source is absorbing power, not this is not supplying power. And current in this 20 volt source is 5.5 amperes, current in this 10 volt source is 2.5 amperes. So in that way, voltage in between AB nodes is 5 volts, voltage in between AB nodes is 5 volts, and current in this 5 volt source is 3.5 amperes. So I have taken this problem from IIT tutorials.